So we're going to analyze this graph. Uh, One thing, if you remember, I always said that the domain was usually the independent, and it's usually the x-axis. That's like 99% of all the math you're ever going to do is like that. There's very rare cases where it's not, but that's really complex stuff that you don't have to worry about right now. It's like differential equations, which is the class you take after calculus and stuff like that. It doesn't happen very often. So here, this graph represents the distance Francesca has ridden on her bike, and we're going to describe what's happening in the graph. So what happens here? Someone is at their home, and they jump on their bike. Let me draw a little bike out here. And then they ride somewhere, right? Now, is it a perfect ride the whole way, or like, or is there stop signs, or are there hills they have to climb, or they go slower? Where's their final destination at? How far away is that? Like if I ride my bike to the college, there's a big hill going up to the college. I'm gonna have not be going as fast when I'm going up the hill. So since I'm not going as fast, my distance isn't growing as much. So the way you want to think about these things here is the x-axis is the independent, it's time. The y-axis is the dependent. So think about as time changes, what is happening to the distance. So she leaves her home and she goes steadily away, right? When she leaves home, she moves steadily away. And that's what's happening in this green part of the graph right here. Right? I'm going to put a little green dot there so you can see how they match up together. But then what happens? It gets flat, right? The distance away from home stops changing. Let's highlight that in red there. It gets flat. It's not changing anymore. So what's happening there? Maybe she stopped by her friend's house. Maybe she went to the park and sat there at the park for a while. Maybe she got stopped at a stoplight for a really long time. So what's happening there is then she stops for you can use whatever kind of adjective you want here. I'm just going to write for a time. Because I don't, is this 2 minutes? Is it 30 seconds? Is it an hour? I don't know how much time is actually happening here because they give me no numbers. But there's some amount of time that she is stopping. And the last section is she starts going away, right? And she starts going further away. Now the difference here is, does the green line or the blue line look steeper? Because the steeper it is, the faster she's going, right? So she starts moving again. She starts moving away from home again. And to me it looks like it's slightly not as steep, slower than before. And that is the blue part of the graph there. So that's how you describe it. You just think of like, okay, over time, the distance is increasing. She's going somewhere. Distance is not increasing. She is stopped. Distance is increasing again. Now she's moving again. And I can even tell that she's not moving as fast as before because it's not as steep as it was. This is a hard thing to do. You're gonna try some, and I imagine when we go over these problems as a class, it's going to take us some time to really take a look at all the different graphs that are happening and really try to understand what's happening. So make sure you try a couple of these things. Make sure you can really understand what's going on. But if you don't get to all of them, that's okay. You're going to want to make sure that you choose the one that is about these on the selected problems, though, for sure. All right, I'll see you in the next section.